We are going to use the graphing guidelines to sketch a graph of y equals 3x divided by natural log of x. First, identify the domain. This function, we know that the denominator or the natural log of x cannot be 0. Therefore, x cannot be e to the power 0 or 1. With the restriction of the natural log itself, x greater than 0. With these two conditions combined, we get the domain of this function as the set of x such that x greater than 0 or x cannot be 1. With the interval form, the domain can be rewritten as 0 to 1 and then 1 to infinity. And this graph doesn't have symmetry. Then we're going to find the f prime using the quotient rule with 3 as a constant multiple or the constant coefficient. We're going to take 3 out and find the derivative of x divided by natural log of x using the quotient rule to get natural log of x multiplied by 1 minus the x multiplied by the derivative of log x, which is 1 over x, divided by the quantity log x to the power second. And simplify more, we get f prime as 3 multiplied by natural log of x minus 1 divided by the quantity log x to the power second. And also find the second derivative. Using the quotient rule again, we get 3 multiplied by 2 minus log x divided by x times the quantity log x to the power third. Use the first derivative to find the critical value. Let f prime be 0 or look for the case at f prime undefined. For f prime equals 0, we look at the numerator of the f prime, which is 3 times log x minus 1 equals 0 and solve for x to get x equals e. For the f prime undefined, we look at the denominator and let it be 0. So natural log of x squared equals 0, or we get x equals e to the power 0 or 1. Since 1 is not in the domain, so we ignore this number. We consider x equals e. Draw the real number line. For this function, the domain is the number greater than 0. Skip the value 1. So this is the undefined point. And locate the point E, which is the critical number. And we look for the sign of the f prime. For the sign of f prime, any value that greater than E, the f prime gonna be positive. Between 1 and E, negative. And also between 0 and 1, the sign of f prime is negative. So we have the interval of increasing as the interval E, comma, infinity, the interval of decreasing 0, 1, 1E. So we have two intervals. We have skipped the point 1 because 1 is not defined, or the point that the function is not defined. And since the sign on the left and on the right side change, the graph is decreasing on the left, increasing on the right. So at the point x equals e, give us the local minimum point. So the local minimum point is e, the function at e, or we plug it in the original function to get the function at e equals 3e, or the order pair e, 3e. And next, we're gonna use the second derivative to find the interval of concave up, concave down, including the inflection point. So f double prime equals 0, or the case at f double prime undefined. from f double prime in the form of 3 times 2 minus natural log of x divided by x times the quantity log x to the power third. So the numerator equals 0 for the case that f double prime equals 0. So 3 times 2 minus natural log of x equals 0. Solve for x to get x equals e to the power second. It's in the domain, so we keep that point. For the undefined case, the denominator equals 0. We got x equals 0 from one of the factors, and the other factor give us natural log x equals 0 or x equals e to the power 0 or 1. Again, both x and 1 not in the domain of this function, so we discard these 2 points. Target on x equals e to the power second. Draw the real number line, the domain, anything above 0, skip the value 1, which is the undefined point, and then locate the point x equals e to the power second. And this is the line for the f double prime. We are going to find the sign, either positive sign or negative sign of the f double prime in each interval. For the interval that's greater than e to the second, pick the number to find the sign of the double prime. We get the sign negative on the right side of e to the second. And then between 1 and e to the second, the sign of f double prime is positive. Between 0 and 1, the sign of f double prime is negative. With the sign of the f double prime, we can say that the interval of concave up plus sign gonna be 1 comma e to the second. And then the interval of concave down, where the sign of the second derivative is negative, gonna be 0, 1, and e to the second to infinity. And at e to the second, the sign changing from negative to positive. From positive to negative. So from concave up to concave down. So this is the inflection point. At e to the second, f at e to the second, and evaluate the function at e to the second, we obtain the value as 3e to the second over 2. And put all the points together. As you see in the graph, the function is defined from 0 until 1 and then after 1. So interval 0, 1 here, and then 1 to infinity. The local minimum occurs at E3E, and the inflection points occur at the point e to the second. That means the sign of the second derivative changing from concave up to concave down. And the other portion of the graph between 0 and 1, the graph is concave down. But the sign doesn't change at 1, and also 1 is not included in the domain.